Yes, the party that last night wasn't that late, was it? Can everybody hear me in the back? I assume so. Yes? Okay. We're going to talk about the plugin system in Drupal 8. Basically, if you know Ctools from Drupal 7, if you know the hook system, we replaced that with something new and really cool. This is me. My nickname is Xano, Twitter handle, and my website. If you want to look me up, see what the hell I've been up to. And my pointer doesn't work. I think I'm going to have to do it without batteries this time. All right, I am actually going to find batteries because this is really annoying. My apologies. Shafi, do you have AAAs? Two of these. Anyone?
Oh, what is it for?
My remote.
Oh shit.
They ran out.
Kérdezzem a macsit?
Okay. All right, I'll just start without. Okay, thanks. All right, the lovely organizers are trying to find me some batteries. All right. So first of all, if we're going to talk about plugins, we need to know what they are. Basically, if you have a plugin type, it's a particular piece of functionality that you can swap out for another implementation. In a very abstract sense, you could have a cache backend, which is pluggable because you can have a backend that stores items in a database, that stores them in memory, but they're not technically plugins. They're swappable though. What we call a plugin in Drupal 8 is something that is uniquely identifiable. It's not just swappable like a cache backend, but we can also identify which particular implementation we're talking about. We don't know that about cache backends, but plugins in core like views, fields, field types, they have IDs, they have machine names. We know if we have a plugin, what its name is, what its ID is, and if we have a plugin ID, we can retrieve a plugin based on that. Plugins have metadata, basically static information that describes the plugin. A human readable title, maybe some route information, other information for the admin panel. It defines the plugin. It doesn't change on runtime, but it doesn't contain any logic. That is part of what we consider a plugin there. And this is one of the most important things in Drupal 8. If we have a plugin of a particular type, we can create multiple instances of it. Take the powered by Drupal block. Blocks are plugins in Drupal 8, and one of the limitations in Drupal 7 was that of every single block, you could only have one instance per theme. Well, you can now have multiple instances. So if you have the powered by Drupal block or the search from block, you can have multiple versions of those, multiple instances in the same page. So the way we did it in Drupal 7 in core was really just hook discovery. Discovery is really the technical term for, okay, we want to know what plugins of this type are available in the system and then get the metadata about them. We used hooks for this in Drupal 7. Most of the contributed modules used hooks, with a few exceptions like the modules that were using Ctools, which used a file-based discovery mechanism where the information about the plugins was located in a particular file in a specified directory, which works well, but it's a slightly different method of finding or discovering the plugins that are available. A lot of these things use magic callbacks or hooks or magic file includes that were not really explicitly specified, but that the system tried to load them automatically. Wasn't always very well documented. This also means that the actual code of the plugins usually lived somewhere else than where the metadata was defined. So you have a hook implementation here with information about your blocks, and then you have a hook implementation elsewhere with the actual block logic of the contents. So it's kind of spread out across the system, hard to find, hard to maintain together. Some plugins are actually classed, which is, for instance, the views field plugins. Basically, any field a views plugin in Drupal 7 is a class. But the plugins in core, they're just functions. They're magic callbacks. This is really confusing. We have all kinds of different methods in Drupal 7 to extend the system. They're not consistent with each other. The way that you, as a developer, use these plugins differs per plugin type. The way that you, as a developer, provide plugins for the different plugin types is also very different. It's confusing. It's difficult to work with. You can't make generic features for all these plugin types. So in Drupal 8, we have something really cool. All our plugins are classes, always, no exception. There are no magic functions. There is no global stuff. Every single plugin is a class, period. Which is cool because you have all your logic together in one place. Also, with the auto-loading standard that we use in Drupal 8, we have one class per file. So apart from the plugin, there is no other code in the same file. So if you want to move a plugin, you just move the file. Ideally, every plugin, which is a class, should implement an interface. The cool thing about PHP interfaces is that they cannot contain any logic. You just define constants on them. You define methods on them. You really just define the required functionality of a particular plugin. And how that plugin does it, that's up to the class, which is a very nice abstract way of thinking. Most core plugins do this, actually. They implement interfaces. They provide base classes for the easy stuff, so you don't have to deal with setting basic properties yourself. The boilerplate scaffolding is already there for you. Some plugin types, like those for views, do not have interfaces. They only have base classes. Those are the exception in core. Thank you. Really just because views was one of the first things that was ported to Drupal 8 before the plugin system was really completed and before we had a bit of an idea of what the hell we were doing, because we learned a lot when developing Drupal 8. We started out 5 years ago. A lot of us weren't experienced with object-oriented programming. A lot of us still are not experienced with it. And we learned while we did it, so that's why you'll see some plugin types that are better than others. Ideally, this should work now, because my laser pointer works. Oh. Usually works if you put the receiver in the USB port. Okay, yes. And this is the most awesome part of the plugin system. We have a consistent API that you as a developer can talk to if you want to deal with plugins of a particular type. We have plugin managers, and they work exactly the same. So how they internally discover plugins, how they internally instantiate plugins, that's up to them. But they all implement the same plugin manager interface. They all provide you with the exact same methods for discovering plugins, their metadata, and creating instances. Which means, as a developer, you have to know a lot less. There are no many different ways of dealing with plugins. There's just one way, which is easy to learn. And if you learn that, then you can deal with any different plugin type, as opposed to having to deal with hooks, with Ctools, with classes. So no more dark magic. No more magic functions, includes, callbacks, hooks, whatever. Everything is very explicitly specified in classes. Everything is very consistently done in plugin managers, which makes it easier to learn, which makes it easier to swap things out, and basically less frustration, more fun. So this is the basic overview of the plugin system. Before we go on, there are a couple of terms and phrases that you need to know and that are highly confusing if you don't know them. So the first thing is the plugin type. A plugin type is, for instance, a block. A field type is a plugin type. A field widget is a plugin type. What do we have? Image effects are plugin types. And then for every plugin type, there are plugins. So we have multiple different blocks. We have a Powered by Drupal block. We have a search block. We have blocks for every menu. And every plugin has a definition. Every definition is for one plugin, and the definition is the metadata. It's the static information which contains the plugin ID, maybe the human readable label, and you can add all kinds of things to that depending on the plugin type. So one plugin, one definition, those are kind of together. So in order to find the plugins that you have in the system for a particular type, you need this discovery method. It basically finds the ones that are available. There are a couple of different methods that I will show you later. And once you've discovered these available plugins, you want to use them. So you have this metadata, but you want to create a plugin instance, which is really just an object. And that's where the plugin factory comes in. Every plugin manager is also a plugin factory, and it has a create instance method. You give it the plugin ID, and it gives you an instantiated object for that plugin. So the plugin manager really is a useful toolbox. It does the discovery for you. It does the factory for you. You basically pass it around in the system, and it has everything you need to deal with plugins of a particular type. Every plugin type has one manager. One manager is for one plugin type. And depending on the plugin type, a manager can do more. Some managers have some helper code for building user interfaces. Some plugins are categorizable. There's some helper code for that on plugin managers. But the discovery and the factory are the two really fundamental things that every manager must always do. So we've had the factory, which creates a plugin instance for us. And a plugin instance is based on its definition. The definition contains the name of the class that is used to create an instance of. And then when creating a new instance of that class, the plugin definition is injected into it. So any plugin instance knows about its definition. So you could say that the definition is also some kind of a configuration for every plugin instance. But the most important thing about a plugin definition is that it can never change. For every instance in the system of a particular plugin, their definitions are always the same, and they can never change during the lifetime of that instance, of that object. So you may have noticed that there's this particular limitation that you can't change this configuration, and that's why we have plugin configuration, which also defines the behavior of a plugin. But what we call plugin configuration can be changed during the lifetime. Two instances of the same plugin can have different configuration. Once you create an instance, you can pass on configuration, but you can change it while passing the object around. And this is cool because you can import and export the configuration of these plugins. Any plugin that implements this interface has a get configuration and a set configuration method. And using that configuration and its plugin ID, you can recreate the plugin later on. So if you have a plugin now, you want to configure it, or you have a UI for it that site builders can configure the plugin instance with. You get the plugin ID from the plugin, you get the configuration from the plugin, and you store it somewhere, maybe in your configuration system, CMI. And then later, when you actually need it, you load the plugin ID, you load the configuration. Well, you know the plugin type that you're dealing with, so you get the plugin manager, and you create a new instance using the plugin ID and the configuration, and you have a plugin instance that works pretty much the same as the one that you configured earlier. They're not technically clones. I just wanted a nice picture. Because it's an object. Objects can have properties. I mean, configuration is importable, exportable. It doesn't necessarily map to class properties. So technically, it could be that if you recreate an instance, it works slightly differently. But for all intents and purposes, this is what we use it for. And it has worked really well for us so far. So I talked about the discovery methods. There are a couple of different ways that you can discover plugins in the system. There are two really important ways. There are a couple of other ones that we have in the system but that we don't really use. The most important one is annotated class discovery. Code example following in a minute. This is a really cool one because you have the metadata in the documentation block above the class, which means your metadata and your logic are in the same file. Nothing is spread out. Everything is together. If you want to remove the plugin, you remove the one file and you're done. You don't have to do anything else. The other one is YAML discovery. And as you can see in the brackets, there are two different reasons, or there are different reasons for choosing between these different methods. Because if you have an annotated class, you must write a class. But if you don't have any different logic in your class, you just want to reuse an existing one, then why should you write a custom class? It's kind of ridiculous. You have a class that is empty, that extends a parent class, but doesn't do anything. That's where we have the YAML discovery. In your module root folder, you have a YAML file for this particular plugin type. And it's basically a nested array with the plugin definition. And the plugin manager uses a default class for all of these. You can usually override the class if you do actually want to have some specific logic. But for instance, menu links in Drupal, we have never ever found someone who wants to have custom menu link plugins in core because the default logic really works for everybody. The definitions, however, are different because they contain the menu link titles, the descriptions, the paths at which the menu links are supposed to be displayed. So that's different. So we do want to specify that, but the logic is the same. So with a YAML file, we only have to specify this definition, and we don't have to do any weird shit with logic that we're not going to use anyway. There's the third one, which is static discovery, which is really just, it's a class that you instantiate and you literally encode set to your plugin definitions on it. We mostly use it for testing because it's an easy way to provide discovery. It doesn't have to be pluggable, it doesn't have to be extensible, because we just really want a dummy discovery thing with a few definitions on it for testing. This is a legacy thing, don't use it, it still exists. It basically is the same thing as in Drupal 7, but wrapped in a class. It used to be a backwards compatibility layer thing that we still used when we had a few plugin types left that we used hook discovery. So you can't change the entire system in one go. You'd have a patch that's 50 megabytes and nobody wants to review that. So we swapped to the new plugin system, but this class allowed us to have a few plugin types left that still used hook discovery. We don't have any of those left, but we were in code free, so we can't remove this class technically. So this is what an annotated class looks like. This is actually, apart from the fact that there's no code here and there's a little bit of namespace stuff missing on the top, this is actually an example from Drupal core that I took out this morning. This is a views display plugin that ties into the REST system. And an annotation is really nothing more than something in a doc block with an @ sign in front of it. You may be familiar with things like @param, @return, @var. Those are also annotations, and they have been around for a long time. They're used for documentation. PHP unit, if you come from, if you've already done Drupal 8 or you come from outside of Drupal, PHP unit uses annotations to do things like code coverage or to set expected exceptions in code, data providers. And we use it for plugins to do the metadata. So this is really a documentation annotation. And this is the plugin annotation that we use. It starts with an @, it has the name of the annotation, and this is really, it's kind of a associative array notation in a code comment. This is the plugin ID, we have a human readable title, and this is also an annotation. So we have an annotation in an annotation, inception. And we do this one particularly because this allows us to have a translatable string, really. We want plugin names to be translatable because if you're German, you might not understand English or the other way around. And because it is static data, you can't use the T function. So this is our workaround. You see a few other things, booleans here. These are the keys for this particular plugin type. They're different for every plugin type that is in the system. So you just add this in the doc block above your class. Your class must be in a particular file path, have a particular namespace. It's usually documented fairly well. You just add this, and basically the annotated class discovery finds your class in the particular directory that it is looking for, and then it scans the doc block of that class. And then it extracts the bit with the right annotation name, and then this becomes the plugin definition that you get when you ask the discovery method, give me all the definitions of the plugins of this type. This is what you get. This is YAML discovery. There's no class. This is just really, really simple. You don't have to know any logical programming skills to be able to edit this or add a file for this. You can easily change it. As you can see, this is actually a human readable string. It is translatable, but there's nothing around it. There's no T. There's no @translation. The POTX module has a YAML translation patterns.yaml file, which allows you to expose which keys in your YAML files are translatable. It's not very stable yet, but it will allow you eventually to tell the system that it needs to extract these as translatable strings. So a little beyond the scope here. Ask me more about it later if you are interested. Yeah, so inevitably we come back to forms because Drupal is not like Symfony, it's not a framework, it's a CMS, and it's intended to be used through the user interface. So as I just told you, every plugin can have configuration, and that's cool. That's really cool. You can import that, export that out of the plugin instance, but how do you change a plugin's configuration? Maybe the plugin offers methods on its classes to do that. That's a little boring, because then you have to be programmed to change it. Plugins can also provide their own forms with which you can change the internal configuration of the plugin instance. There's the plugin form interface. If you implement that, it has build, validate, and submit methods. pretty much the same concept as we're used to in Drupal 7. It's just that these things live on the plugin instance. They return form elements that are embedded in a parent form. They're validated, and in the submit handler, the values from that form are saved into the plugin instance. If you then want to store the configuration on file, you just use the get configuration method on the plugin, and you get the array of plugin configuration. Core uses it. We're going to be writing, I'm going to do some live coding later on where we're going to write a block plugin with a form. This is a really cool and difficult bit of the plugin system. Because we've seen a few different methods in which we can expose a plugin to the system. We can use an existing class and add some definitions to a YAML file. We can add a custom class with an annotation. But that only works for one plugin. We write one entry in the YAML file for one plugin. We write one class for one plugin. But what if you want to create a lot of them dynamically? That's really, really difficult. Because if you create a menu, you want a block to be available for that menu dynamically. You don't want to do any coding. And that's where derivatives come in. And derivatives, the concept is really that you can expand a base plugin definition, and a base plugin definition is one that is defined in a YAML file or as an annotated class. You can dynamically expand it into multiple other definitions, replacing the base definition. And we use that for these menus, for instance. There is a menu block in the system. I think it's called system menu block if you want to look it up on the laptop. And in this annotation, it has a key called deriver, which is the name of a class that can automatically, dynamically return any number of definitions that replaces this base definition. And what we usually do is that all the definitions returned by a deriver, they use these values from the annotation or the YAML file as default values. So usually these derivative definitions, they only override a few values like the human readable title because you want a menu block to be named after the menu. You don't want it to be called menu, you want it to be called administration menu or user menu or whatever you have in your system. So it automatically expands it. When you add a new menu, the system clears the caches, and the next time the system wants to know about the blocks, it finds the system menu block in the system. And then when parsing its definition, it sees, oh, there's this deriver key. So it loads the deriver class, and it asks the deriver, OK, we know that you want to dynamically declare all your definitions. Give them to me. And then it can return one definition, it can return 10 or 10,000 definitions, and those definitions all replace the one base definition defined in the file, the class, or the YAML file. It's a little abstract, but it's a really, really powerful tool to dynamically expand the system without having to write any code, or hardly, because the deriver can be really small. What we do in system menu block is the deriver loads all the menus in the system, and then for every menu, it just creates a definition. So it takes the menu storage object, and it loops through the menus that it gets, and just returns an array with all these definitions. It's fairly simple. I can show it to you on screen. Takes a bit of getting used to. It's definitely worth keeping in mind when you're writing modules for your Drupal 8 projects. As usual, Core does a lot of cool things, but it's not cool enough. In Drupal 7, we had the entity API, which was really, really awesome. And then Fago was like, I can do better. There's a lot of stuff missing here. So, same thing with the plugin system. There's a bunch of the stuff that we thought was missing. So there's a plugin module that extends Core's plugin system. A couple of things that it does that Core doesn't do is discovering the types of plugins. So in Core, you have plugin discovery. And that means you have to know which plugin type you're dealing with. You have to hard-code it in your code, get the plugin manager for blocks or for field types. And then you can find out which plugins are available for the type. But if you want to write a bunch of code that can work with any different plugin type in the system, there's nothing in Core that can do that for you. So that's what the plugin module does partly. Any module can expose their plugin types. It also through a YAML file, coincidentally. The plugin module does it for Core. Any contributed module can just add a small YAML file to their root folder to tell the plugin module, hey, I provide these plugin types. this is how you get the plugin manager. This is the human readable label. Have fun. The reason why we need this, I'll show you later. This is more of a, this is Amsterdam, actually, very nice city. I live there. Come visit. This is really more of a tiny useful tool. It doesn't actually do much, but if you just install Drupal core, you have no idea which plugin types are available, and you have from the user interface. So if you're a coder, you can look it up, but if you're not really a coder or you don't want to look in the code, you can't figure out which plugin types the system uses and which plugins are available for these types. The code can do it, but it's kind of a hassle to go through the code and find it out. So the plugin module provides 2 administrative pages, basically, that list the plugin types and then the plugins for every type. The configuration system is new in Drupal 8. For those who haven't gotten around to checking it out, basically all the configuration in Drupal 8 is stored in YAML files. Again, YAML, there's a lot of that in core. Which is cool because then you can put it in Git, version control your configuration, you can deploy it more easily. But for every configuration we have in the system, we need a schema that provides the system with metadata about what the configuration is. Maybe it's translatable configuration, so we tell the system this is a string, it's translatable, and then the configuration translation module knows, we need to provide a translation form for this. And there are a few other things that this system does. But if you want to store the configuration of a plugin, because we already can import and export it out of a plugin instance, but we want to store it in a configuration file, and maybe part of this plugin configuration is indeed a translatable string. So we need a configuration schema for that. And some plugins in Drupal core already have these schemas, but again, you have to know the specific naming convention for that plugin type to be able to use its schema. Which is not really useful if you want to write generic code that works for any plugin type. Also, come back to that later. So what the plugin module does is it provides a fixed format for your configuration schemas. It's plugin.plugin configuration dot the plugin type ID dot the plugin ID. Because plugin IDs are unique within a particular type. You can have plugins with the same ID, but as long as they're for different types, they never clash. So we need both of them in this naming convention. But they're a fallback. If you do not provide a schema, it just uses, this is not just a wildcard, this is also actually the name of the fallback configuration schema that just says, oh, ignore this configuration. But you can also just only replace the first asterisk in your schema with the plugin type ID and leave the second asterisk in. So you have generic schema for all your plugins of that type. You can, like with theme suggestions, you can be more and more specific the further you go down the name. One of the problems with the plugin definitions is that there are arrays. And the thing with arrays is they're untyped, you don't know what's in them. Technically, arrays are lists. So basically, all the values in an array should kind of be the same thing. But we don't do that for plugin definitions because one key is the plugin ID, the other key is the human readable label. Basically, semantically, all these values are different. And what's worse, a lot of plugins in core use the label key for the human readable label, but the block plugins use the admin label key. Try generalizing that in your code. So what the plugin module does, at this moment we have plugin definition mappers. They're basically classes that have methods that extract the right values out of arrays for the particular plugin type. And we're moving to a point where we have actual definition objects, which is a little nicer, which might also end up in core in the future. And once you have your array definition wrapped in one of these objects, you can just call the same methods all the time, and the object itself will make sure it extracts the right value from the array. Plugin selectors are really cool. We already talked about the fact that plugins can provide their own forms to configure their instances. Plugin selectors basically allow you to let your users choose a particular plugin, and then once they've chosen that plugin, the form of that plugin is shown in the UI. You can configure it, you can save it, and then the form can extract the configuration of the selected plugin and the plugin ID to store it on file to recreate that plugin later on. The plugin module ships with 2 basic selectors, radio buttons, and a select drop-down list. There are ideas for rules to make it all JavaScript powered. It takes a lot of form API handling out of your hands because it stores a lot of temporary data if users want to go back to the previously selected plugin. Those are hundreds or thousands of lines of code. If you want to write that yourself, it takes a long time. It's already there. it's pretty damn useful. Take a look. This is actually also why we want to generalize plugin definitions, why we want to generalize plugin type discovery, because these things work with plugins of any type. So they need the typed plugin definitions, so they can just talk to that interface, that class, and the class is responsible for extracting the right array elements. This thing just wants to talk to one generic API. There are field types. The module provides a field type that lets you save plugin instances on content entities. One of the examples that I've done is I maintain the payment module. Payment methods are plugins, and there's a payment method instance saved on every payment content entity. The payment method instance contains a few different things, like maybe the account number of the customer who paid for it, or their bank. You know, the non-security sensitive information that is important to that particular payment and payment method. But it's on a content entity, so we can't. There's a bit of a complex issue with storing data on content entities. Everything has to be a field these days. So we've had to figure out a way to store these plugin instances on fields. So there's a field type that uses derivatives to dynamically check which plugin types are available in the system. So now it all comes together. For every plugin type in the system, it creates a derived plugin field type. So there is I can show you in the admin panel later. There's a field type for block plugins. There's a field type for payment methods. There's a field type for image effects. How useful that is up to you. Do something fun with it. And then for every of these field types, there are widgets, because you need to kind of configure the default values for these fields, or when you want to create a new entity in the entity form, you want to configure the instance as well. We already had the user interface in the form of plugin selectors. So every plugin selector is a widget for these fields. So out of the box, we have two widgets, the radio buttons and the select lists. The formatters are a little less exciting. There are two basic formatters. One just displays the plugin label. The other one is specifically for blocks. It renders the block. The reason this is a little less exciting is because plugins are usually not displayed. So there's not really a generic solution for that. But we are working for another issue on some kind of renderable interface, which we can use to render plugins that implement the interface eventually. It's a little bit for the future, but that might get more exciting. OK, so this is actually the end of the original presentation, but we're going to do some live coding. So hold your breath. Maybe, although I can probably answer a few questions right now about the slides. If you have anything big, leave it till the end. Was there anything unclear so far? No? OK. I'm going to show you a few of the admin pages, and then we're going to write a block plugin, for which we have an hour left even. Yes? Is this
but maybe
Hello?
better in the end.
This is on? Yes, question.
No, it's about the derivatives. I don't
Okay.
think I fully understood how they work and what exactly they do. More or less, I guess. But show your coding, and then maybe I will understand.
So we have the, where is my Drupal 8 install again? Where do I have it? Oh yeah, Drupal, yeah. All right, cool. Let me enable the plugin module. Plugin. Cool. So this is a fresh Drupal 8 install from this morning, created specifically for you. So we're going to the plugin modules. Where did I add that structure? Yes. So this is the app administrative overview. These are all the plugin types that the system knows about. These are all added in the YAML files that I talked about, and these are pretty much the core plugins, really. Field widgets. You see the local actions and local tasks are all plugins, just like menu links these days. This is the only non-core plugin because it's from the plugin module. And if you click the view button, you see which plugins are available for this type. So these are the two plugin selectors. And if you go, for instance, to field type, you see these available types. You see which module provides them, You see a few ridiculous descriptions. It's really just to give an idea of what's there. So to give you an idea of what derivers are, hey, beach ball. System menu block. Okay. Yes. So this is the generic block that makes, or the generic plugin that provides a block for every menu in the system. You can see here there's a bunch of logic. It has a form. This renders the block, displays it on the screen. And if we go to the annotation, we see that there's a deriver specified here. So that is the keyword for a class that dynamically provides new definitions based on whatever it is you want. So let's open that deriver. Well, it has to implement deriver interface. The container deriver interface is for dependency injection. Don't worry about it too much. It's fairly generic, but it's not specific to the plugin system. It's a useful concept to know. And if you can see here, it's a really, really small class. So it only takes the menu storage. And then in the method where it is supposed to return these derivative definitions, it just loops through the available menus. It uses the base plugin definition for every derivative definition, and it just changes the label and the dependencies of the new plugin. That's really only what it does. But it also provides a new plugin ID. And this array key is actually the plugin ID of the derivative plugin. And as we know, plugin definitions are injected into plugin instances. So every plugin of this type uses this class. This is the original class with the annotation with the deriver. Here in the constructor, it takes the plugin definition and it contains the ID. So when it displays itself, it can take the menu name out of its plugin definition and use that to load the right menu and display it. It's basically how it works. These derivers are usually pretty small. It's basically they take some required dependencies that they need to get the metadata from the system. They loop through it, and then for every item they return this derivative definition. I suggest you play around with it. It's not something you might need directly. It's definitely good to keep in mind. It's useful for many, many different use cases, from contribute modules to client projects. If you know that it's part of your tool set, it can save you a lot of work.
But so the class that you want to derive from has to know that it will be derived and specify who derives it. So you cannot like take some other class and say, I want to have derivatives of that, if the class itself didn't originally want to do that.
Yes, that's true. You have to specify a deriver here. And you can also do that in YAML discovery. In a YAML discovery file, system links, menu links, you could technically add a deriver key here with Drupal system and then the path to the deriver class. But you must specify the deriver there, otherwise it just won't work. So the deriver is usually also very specific for the plugin class. It's not always reusable. So they basically belong together, these two things. If a plugin has a deriver, these two belong together. If you want to remove the plugin, what I said earlier is you just remove the plugin class. If it has a driver, also remove the deriver class. Because they're separate, they have different responsibilities, but they do kind of belong together. It doesn't matter where you put the deriver class. It matters where you put your plugin class, but not where you put your deriver. As long as you just enter the right path here, deriver, the rover. As long as you enter the right path here, it doesn't really matter where you put it. So we have, let's see what blocks we have in the system, and then add a block to the system to get a bit of an idea of how you write your plugin. I am a developer, so I need to figure out where the blocks are. Yes, okay. So this is basically the Drupal 7 blocks page, but then revamped to Drupal 8. We see a bunch of options here of the available blocks that are in the system. So let's add one. The thing with annotated classes is, as I said before, they have to live in a particular directory. With the autoloading system that we use in Drupal 8, which is not Drupal specific, but it's PHP specific, every namespace maps to a directory. And a namespace is this little thing. It allows us to have multiple classes with the same name without clashing. If you have, traditionally, if you have two classes with the same name, the system will complain. Class has already been defined. If you have a class with the same name in a different namespace, that's okay. That's also why we have, here's the deriver. This is called a fully qualified class name, basically namespace plus class name. So the system knows exactly which one you mean. We use this format. You need it for instantiating new classes, but we also use it for documentation. We can no longer do @return in the class name because then it's ambiguous. The system doesn't know if you mean the one class with that name or the other class. You must do the full name with the namespace in it. It's something you'll get used to. So these namespaces, with our autoloading system, they map to the directory structure. The first little bit, Drupal/system is the module name. This little bit maps to the SRC, the source directory in your module. Everything after that maps to the directories within that source directory. And then the file name is basically the class name .php. As we can see here, our class is called system menu block, and then up here the file name system menu block.php, and you see that the system SRC folder, that's what the Drupal system namespace refers to, and then within there we have the plugin, block, and then here plugin and block. So that matches up. It's an improvement over the Drupal 7's autoloader, which uses database system. This introduces a lot more predictability, no database connections. It's faster, it's more reliable, and it's interoperable with other systems other than Drupal. So what we need to do when we create a new plugin is figure out where we need to put the plugins of the type that we want to add a plugin for. For blocks, it is within the source directory. We have a plugin and then the block folder. It depends on entity types go in /entity, actions go into /plugin action. For field plugins, you go even one level deeper. So within the plugin directory, you go field and then field type, and then you have the class. There's not really a way to remember this. You just have to know it for the plugin type that you're building. So what we're going to do is add a new module to, or a new plugin to the system module, a new block. So we have the system folder, and then we go to source. We figured out that the plugin lives in the plugin/block folder, so it's right here. And we do Drupalaton.php. Now, let's open it up. It's right there. Okay, so we have an empty file. First thing we start with is, I think is a good idea, is the PHP tag, but then let's start with the documentation of the file. Conventions, Drupal, dictate that we have a code comment like this. Plugin, block, Drupalaton. Okay, so this is the first thing. This is all the human readable stuff. This doesn't really matter still. We do have to define the namespace though. So the font a bit bigger. Is that editor? That didn't work. Just
presentation will be
as you can see, this is my first live coding thing in the presentation mode. That's really useful. Oh, great. See, I learned a thing. Okay, cool. So we need to define the namespace. Otherwise, the class cannot be found. The auto-loading system doesn't work. And then we say, okay, we provide a Drupalaton block, because we all love Drupalaton, we love blocks. So we start with the class name. Okay, cool. We have a class. We basically have a plugin. But every block plugin needs to implement that interface that I told you about. The interface is really a contract. It doesn't contain the implementation. It really just tells the system, like, this class pretends to be a duck. And it can be a duck with a high-pitched quack. It can be a duck with a low-pitched quack. It doesn't care as long as it's a duck. As long as it is capable of quacking and swimming. And then how fast it swims is also irrelevant. So Ruben is a duck. Block plugin interface, yes. and now we see it bitches and moans because, oh, yes, we have all these methods that it must implement in order to be a block. Luckily, we have a base class for this. So we block plugin base. Block base. Two things are difficult in computer science. Caching things and most importantly naming things in this case. This is not the, is this the block plugin base? Yes, this is the block plugin base. And in presentation mode, my PHP server freezes. Thanks a lot. Cool. Okay. But because block-base already implements the right interface, we can leave this little bit off. It will still bitch and moan about one method that we have to implement ourselves. So what do we want our block to do? What do we want the Drupal block to say when you display it? What? All right. I'm not going to load pictures, but we can do some with the boat return. So we have to return a render array. So we still have those in Drupal 8, unfortunately. We still have nested arrays of arrays. But what we can do is say, oh, I am on a boat, says Ruben. We make it a quote, right? Because Ruben said it. Says Ruben. See, I can spell your name. Cool. Now we also see that this red line here disappeared because we implemented the one method it was supposed to implement. Because now we rename it, and now it whines like, oh, you need the build method. So we now.
It should be only a colon now.
What did I do now? Oh, right, yeah. I'm a very bad PHP developer. This is, I'm ashamed. So now we have our basic block really. What we can see that just happened actually is that we have these lines with use in front of them. And, well, this one's great, we don't need it anymore. As I said before, now with these namespaces, we need the full namespace to identify a particular class. But if we have to type all these namespaces when we're actually using these classes in the code, we get a long line. We don't want to have to type this everywhere in our production code. It makes the code unreadable. So what you can do is have a use statement or an import at the top of the file, like this one. It's really just an alias kind of thing, but it allows us to use the actual name in the logical code, which makes it a little bit more readable. Nothing Drupal, just PHP 5.3 or 4. So that's why it's not in Drupal 7. But it's a useful little feature. So now we have our block actually. Well, coding standards dictate that we do like a very nice inherit doc block here. And now we're pretty much done really, except for the fact that we have a plugin in the right place. We have a plugin that implements the right interface that actually does something. But as he very aptly noticed, it's not discoverable. The system can find the class, but it doesn't know anything about the class because the class doesn't tell the system, I am a block plugin. So that's we're going to change that. We need the annotation, and I'm going to be really sneaky and copy the one from the system menu block a little bit because I don't know the actual notation. I don't like the presentation mode. All right, we're going to add this a little bit and be so. We have a we need the admin label actually. We have a Drupal block, so we could call it Drupal, but as with everything, if you add something of your own to a generic system, you have to prefix it with your own name. So we're in the system module. Don't hack core. No kittens will die now, I promise, but you should be doing this at home. But we're still in the system module, so we have to prefix this with the module name. If you write plugins, IDs should ideally be prefixed with the name of the module that provides the plugin. Prevents collisions because just like class names, also plugin IDs can collide. So this is really all we need. We have the ID of the plugin, so the system can identify the plugin, and we have a very nice name for in the user interface. And we're actually pretty much done. So let's give Drupal a kick and tell it to rescan for new plugins. Drush CR is the Drupal 8 equivalent of Drush CC, which was used for Drupal 7 and before. All right. Actually, I'm going to show you something else first, because it should actually now show up here and on the list of block plugins. Yes, we have a Drupal block. So the system now knows the block exists, and we can use it. I do have to admit that I have never used this new UI yet, and they recently changed it. So I think place a block. Let's just throw it in the header somewhere. Actually, I want to do it in Bartik, so we can do it on the. This is Bartik on the front page. Let's scroll or filter. Drupalaton. Place. Yeah, category system, because it was from the system module. This is really just a block configuration page like we're used to in Drupal 7. We just have a nice fancy little overlay pop-up for it. This is actually what you see here. This is the block plugins configuration. We didn't actually add the configuration from ourselves, but we inherited it from the parent base class. So we see the familiar visibility restrictions. We have some cool caching things now in Drupal 8, also for blocks. We can toggle the title just like we did in the past. And we save it. All right. And here we see our newly placed block. So let's go to the front page and see what this does. Yes, Ruben is right there in the corner saying, I am on the boat. Thank you, Ruben. And you can do a lot of cool things with this. Block plugins in specific, they just return a render array, so you can do images, you can do forms in there, whatever you want. Actually, the search form right here, in the same build method that we just implemented, it returns a form. Just as a render array. You can do that. All right, was this clear? Are there questions about this? It is super easy, yes. I really suggest, like, we have about a day and a half more of sprinting left. Depends a little on when you go home. We will be in the sprint room for most of the time, except when we're outside in the sun. If you have any questions, if you would like to try and write your own plugin, drop by in the sprint room if you haven't been there yet. It's right in the hallway. We will happily help you out to try and write this yourself. It is the way of extending Drupal 8. I'm going to stand up again. There's not really another way of extending Drupal 8 like this. There are a few tiny things that are really, really technical, but this is the 90% use case, really. So I suggest you try it. We can play around a little bit. I can shoot you an issue that you can help work on so you can get some Drupal 8 credit. Questions about what we just did, the live commit, the slides that we saw? I know it's really overwhelming. Is this something that can help you on your way? Are you confident that you can build block plugins now, or any kind of plugin? I see very difficult faces with little shards of confidence here and there. Okay, let's switch back to my slides. Because yes, thank you for being here. I will put the slides online hopefully today. If the Wi-Fi, it's very image heavy, so if the Wi-Fi doesn't cut out on me, they'll be online today. Otherwise, back home. The plugin module that we talked about is just a project. It's right there. Stalk me again. If you want to take a picture to get the URLs, know where the slides can be found, do it now before I disconnect. If you really don't have any questions, I want to thank you for coming. Find me in the sprint room if you do realize that you want to know something. Thank you, and enjoy your stay here. Was the derivative bit clear in the end?
Basically, you provide your own derivatives for your own classes. You cannot add derivatives to other classes.
Yes, yeah.
Like you for your own plugin.
Yeah, there is, plugins have alter hooks, so we still do have hooks, but for things like altering and events. But I think those kick in after the derivatives have been created. Yeah.
So you want to alter them.
Yeah, so you can't alter in a deriver into an existing plugin.
I think if you really want to do this, you can extend a new plugin that extends the plugin you want to derive. Put that a derivative, and you just inherit all the code from the
Yeah,
plugin.
Yeah.
Yeah, but of course you can extend the class that you want to derive.
Exactly. You don't do anything in it. You just annotate. You can say I want to derive this with this derivative.
Yeah. There are some tricks to make it easier.
Of course, but like it's from the concept, it's the deriver, like the same person that makes the class, or the same, like the deriver and the original class.
They're one, yeah.
Not meant to extend code written by anybody else. It's meant
Hello?
to help you create presentation.
Oh, thank you.
It's not palinka, but taste is good.
Ah. Ooh, very nice.
It's the same.
I'd like to get
Yes, the microphone back.
So it writes this.
Yeah. For example, in rules, it's used to create actions for